So all we're going to do now is look at one particular part of the quadratic formula called the discriminant. And the discriminant is simply what's inside the radical sign. By looking at just that, we can describe the roots of a problem. And so if we look over here at our notes, if we get a number that is bigger than 0, but is in a perfect square, we're going to get what's called two roots, or two answers. If we're going to get a number bigger than 0, but it's not a perfect square, we still get two answers. They're just irrational. If the discriminant equals 0, then we only get one rational root. And if the discriminant is less than 0, then we have a two complex. So let's go through and describe the roots we have for this particular problem. So first, let's identify our A equals 7, B equals -11, and C equals 5. Once we identify it, we can now put it just into the quadratic, or the discriminant part. So B squared, so -11 squared, minus 4 times A, which is 7, times C, which is 5. So let's just do the math of this. This is 121 minus 4 times 7 times 20 times 5, which is 28 times 5 is 140. So this is a minus 140. So 121 minus 141, or minus 140, I mean, is -19, so equals -19. So this is less than 0. So since it's less than 0, we have what's called two complex roots. So the answer to this is two complex roots, which means it never touches the x-axis. All right, so let's look at our next problem and do the exact same thing. So let's identify our A, B, and C. A is 1, B is 22, and C is 121. So now let's just do the discriminant part. So B, 22 squared minus 4 times 1 times 121. And so we do the math. 22 squared is 484. That's 484. And if we do 121 times 4, we get 484. So we get 484 minus 484. So let me erase this. 484 equals 0. So if we get 0, if we look right here, if it equals 0, then we have what's called one rational root. So describing the roots is simply figuring out what the discriminant is. And so we have one rational root.